Hello everyone, my name is Kaleb Byrum, and today I would like to give you a primer on the Bluetooth communication protocol. So in sum, I would like to discuss the historical background of the Bluetooth protocol, as well as the engineering decisions that were made to shape the Bluetooth protocol that we know today. Also, I would like to give you all an example for how Bluetooth works on a hardware and software level. And finally, I would like to give you a practical example for how Bluetooth is used today in regards to the COVID-19 pandemic. Bluetooth was invented and patented in 1992 by Ericsson in Sweden. Its original use was to implement wireless headsets for home telephones. It wasn't until Ericsson engineers met with the R&D department for IBM that they realized the data transfer potential of the protocol. IBM wanted to use Bluetooth technology to integrate abilities for laptops to communicate with mobile phones. Now, mind you, this is back in 1997, years before the notion that mobile phones and laptops were simply partners in crime. After IBM and Ericsson developed the protocols necessary for mobile phones to communicate with laptops, the technology standard was decided to be open sourced, which led to the founding of the Bluetooth Special Interest Group, which today decides and develops the Bluetooth protocol. However, it would not be until 2001 that Bluetooth phones and laptops would hit store shelves, simply because back in 1992, developers had to wait for the technology to catch up so that the hardware could meet the strenuous standards that Bluetooth at the time required. Bluetooth operates at frequencies between 2.402 and 2.480 GHz. This is within the dedicated industrial, scientific, and medical short-range radio frequency bands. Bluetooth divides transmitted data into packets and transmits each packet on one of 79 designated Bluetooth channels, where each channel has a bandwidth of 1 MHz. In low power settings, the bandwidth is increased to 2 MHz, which limits the number of channels able to simultaneously send data. Data is modulated using the Gaussian frequency shift keying method, which is a modified form of digital frequency modulation. Phase keying, which is a modified form of digital phase modulation, is also possible. However, back in 1992, the standard was actually only written for frequency modulation. Connected devices communicate with each other in a round-robin fashion, with each device having a turn in transmitting data to connected parties. However, there is also a scheme of master and slave devices, where master devices control where data goes, while slave devices act as recipients of data. Where round-robin fashion comes into play is that a master device can communicate with a maximum of 7 devices in a piconet, which is a simple name for an ad hoc network of devices. And in this piconet, master devices can actually trade off their responsibility of being a master to a slave device with the consent of the other devices. So in this way, the piconet structure of masters and slaves is actually dynamic and can change depending on the environment of which the network is provided. In this example, we're going to explore how Bluetooth transmits audio from a master device, like a computer, to a slave device, like a speaker. In the top left, you'll find an analog audio signal, which is frequency modulated. From there, this analog signal is sampled at a specified rate, and these samples are transmitted from the master device to the slave device. On the right side of the screen, you'll find how the master and slave devices try to find each other in a network. The way this starts is that a slave device will continuously send out scan invites, which essentially is the slave device notifying that it's looking for a master device to connect to. From there, a master device is also sending out requests called scans, where eventually the scans and the invites will meet each other, which when they meet means that the master and slave device know where they are, know where each other are, and they can now connect. They connect by using an authentication protocol, which is resembled by an invite request and a connection request. And once these requests are completed and fulfilled, the master and slave device are successfully connected to each other and can now transmit data. Now, the direction of data depends on what we're sending. So say we have a computer and we want to send music to a speaker, then data is a one-way street from the master to the slave. However, if we're wanting to send data back to the master, say we are talking on the phone with our headphones, then that data is simply back to the master. And this continuously happens until either the master or the slave device disconnects from the network. And when they want to connect back to the network, they're going to have to go through this authentication protocol all over again, as described by the invites and scan request. And this is done for security reasons. An example of how Bluetooth is used in the real world is its implementation in COVID-19 contact tracing apps. Contact tracing is attempting to learn who has become COVID-19 before they've realized their symptoms, and this is possible using Bluetooth capabilities on smartphones. So, for perspective, in this figure right here, this is what's called the PACT app, which is developed by Raytheon and doctors at MIT, where they're trying to attempt to learn if a cell phone can provide enough data, if logging other phones in the proximity using Bluetooth, to notify other people that they have potentially become COVID-19 positive. The PACT app uses encrypted Bluetooth data to ensure personally identifiable information remains anonymous and also secure. Bluetooth emits pings, which are called chirps, and phones running the application collect and record these chirps from nearby phones also running the app. If a person tests positive for COVID-19, they can upload their chirps for the past few weeks, and others with the app would then be notified for how long they've been exposed to an infected individual. Since COVID-19 patients are infectious before a symptom is onset, or even sometimes they never have symptoms, it makes it even more important that we let the people know that they've become exposed to the virus from someone who has never exposed symptoms. And this is possible, again, using their cell phone. So the use of this Bluetooth, again, allows for the anonymization of this technology, which, as you've probably seen in the news, is a major forefront concern, given past implementations of such applications have really raised flags to potentially compromise the privacy of individuals. In conclusion, Bluetooth is a robust way to wirelessly transmit data between devices that are only a short distance apart from each other. Bluetooth makes use of digital frequency modulation or digital phase modulation to modulate signals between devices. Bluetooth is commonly found in everyday devices due to its practical implementation as well as its cheap manufacturing costs. Because of these two reasons, as well as the already previously mentioned notion that Bluetooth can be found practically everywhere, it can be said for certainty that Bluetooth is here to stay, and more importantly, it will be further perfected in the near future.